In a previous video, I went over how to distribute tasks to different parallel workers in OpenSees MP or OpenSees MPI. In this video, I'm going to go a little bit more in depth to the parallel task load sharing method and go over a file I created that defines some procedures within OpenSees that formalizes the whole process. So first of all, I just have this diagram here showing you a little bit what parallel task load sharing does. So if you have 10 tasks, they need to be assigned between 3 workers. It would start out and assign task 1 to worker 1, task 2 to worker 2, task 3 to worker 3, and then it would wait until one of the workers is available to assign task 4. So as you can see here, worker 2 is the first one to finish, so then it gets task 4, and then worker 1 finishes next, so it gets task 5, then worker 2 gets task 6, all the way 7, 8, 9, and 10. And so this method will distribute the computation time more evenly between processes. So if you happen to have multiple processes that took a lot longer than the other processes, and if they all happen to be lumped onto one worker, then the total duration of your analysis is going to be extended. So this is a much more dynamic and balanced way to distribute parallel tasks. Additionally, because it dynamically assigns them, you can also have some sort of feedback in it, so it's not just all statically defined. So in my previous video, I went over this file called parameter study 2, which dynamically assigns dynamic runs or dynamic analysis runs to different processes. So it sends the AT2 file and scale factor to different workers, and those workers then perform the dynamic analysis. So this is accomplished with the coordinator receiving an available process and then sending to that process the parameters. And then at the end, it sends a closing signal to all the processes. So I basically took this general framework and I formalized it in this MPI test.tcl file here. And what this file does is it creates this namespace and creates some commands in OpenSees called delegate tasks, send task, and receive results. So this basically just adds another layer of abstraction on top of the OpenSees MP commands. And I'll show you a little example of how it works here, and then I'll go more in depth into how it actually works. So all you need to do is you'll source MPI tasks, and that'll define all the procedures. Define whatever the task procedure is. So in this case, I have the simple, I'm adding A and B together. And I'm simulating this long process just for effect here. And so it just returns a value. So basically, I want to delegate this add procedure. It doesn't need to be a procedure. It can also be just a command prefix. That's really what it requires. So the prefix is add, and the inputs get concatenated onto it. In this case, it's just a procedure name. So then inside the delegate tasks body, you can call the send task command, and what this will do is it'll send these values from the coordinator process or process 0 to worker processes. Then at any time during this delegate tasks or outside of it, you can receive results from specific tasks or get a list of all results. If you want to get from a specific task, each time you call send task, it returns a task ID, so you can use that to keep track of which task is associated with what parameters. And yeah, so then as soon as this body of script is done, it'll wait for all the workers to finish, and then it'll share all that information on all processes so that you can get the results of the entire delegate tasks body on all processes. So I'll quick run this on OpenSees MPI with 4 processes on my computer here. And as you can see, it returns the results. It's a list of all the results from every single task, and it's the same on all 2 processes. And yeah, so that's about it as far as how you use it. So And so going a little bit more in detail as to how MPI tasks works. So when you call delegate tasks, you give it a command prefix and a coordinator body. And so if the process is 0, it then goes and it evaluates the coordinator body. And within that coordinator body, you can have the send task command or receive results command as well. And once that's done evaluating, then it gets all the available workers and it sends the close command to them, and then it sends a broadcast of all task information. If it's a worker, then it sends its process ID to the main process, and then it enters a loop where it receives from the main process some message with a command and optionally task ID and task arguments. So if the command is task, then it will evaluate the worker command in the calling scope, and then it will send to the main process like, hey, I am process 2, for example, and I just finished task 3, for example, and here's the result. And I have this reset thing. I can go over that in a little bit, but that's just if you had queried the results from a task, it will basically have this reset command that'll go to it. And then if you get the close statement, then it breaks out of this main loop and then receives the broadcast. And then on all of them, it also returns the result list, but you can also get that with the receive results command. If you call send task within the coordinator body, what it does is, first of all, if you're just running an OpenSees, this will work fine as well. It'll just evaluate the task directly and just append the result list with the result of it. Otherwise, it will get an available worker, send to that worker a task with a certain task ID and input arguments. And then it'll save some preliminary results. So get worker here, this is used in a couple spots in the code. This just receives from any process a message. If the message length is 1, then it's just the process ID. That's the initial message from the process, or if the process worker have been reset. Otherwise, it will receive the process ID and the results from that most recent process. And then receive results. So in this case, it will if you don't specify a task ID, it will loop through all of the current tasks, and if there's any ones that are currently active, it will receive the results from that one and then return the total result list. So this will basically wait for all tasks to be done. If you're waiting for an individual result, first of all, it checks to make sure it's a valid task ID, and then it will go through and check to see, it'll make sure that you're in parallel mode. So if you're not in parallel mode, it'll just return directly the results because you're in series. But if it's in parallel and it's active, then it will receive a message from that process that's assigned to that task. And I have a little error message here just in case if you were using the send and receive messages kind of out of place here. And then it gets all the data from it, and then it sends a reset to the main process. And that's it, really. I know this is a lot. I just wanted to kind of dive a little more in detail in case you're interested. So yeah, this MPI task.tcl file and the example here are on my GitHub. The link will be in the description. Feel free to use it for your own application. Modify it if you want to. It's licensed under MIT license, so pretty permissive. So yeah, I hope this helps. I hope that you learned a little more about how to program in OpenSees MP, OpenSees MPI, and I hope that someone finds this script that I developed useful. So have a great day. Bye.